Hey, welcome back there, sports fans. Today we are going to be discussing projectile motion, and we're going to break this down into some problems. Essentially, we're going to start off with these two equations here. Some of the things that we're going to have to do today is we're going to have to start off by making a list. So one, make that list. Second thing is break the problem into its x and y components. X, y components. And then comes the algebra. We're going to plug and chug. Remember that whatever component they want you to find, you're going to use the other equation. So if they wanted me to find how far away did it land, that means I'm going to have to first then use the other equation to find t. So we're going to plug and chug to find t, typically by using the other equation is how I like to use it, say it. And then we're going to get our answer by using the other equation again, the other equation that we didn't use the first time. So let's go ahead and take a look at our first problem here. A bicycle is traveling 20 meters per second. So, and it jumps off a cliff at an angle of 30 degrees. It lands 4 meters away from the cliff. Find the height of the cliff. So as I start to make this list, xi, xf, yi, yf, g, negative 9.8 meters per second. I just know that automatically. T, vi, y, vi, x. I'm trying to think if there's anything else that we need to know for our equations. I think that's most of the variables there. Oh, and the acceleration. Typically, the acceleration in the x direction is going to be 0. In this problem, the bicycle is traveling 20 meters per second. So I know that it's at an angle of 30 degrees. So I'm going to first of all break this up into its x and y components. X and y. X equals h cosine, let's make it so we can read that a little better, cosine of theta, and y equals h sine of theta. The hypotenuse, it was traveling 20 meters per second, so it's 20 cosine 30, 20 sine of 30. So what I've done here is I went ahead and found out what my x velocity and my y velocity is. So I can go down here and say velocity initial in the y direction was 10 meters per second, and this right here is 17.3 meters per second. Now I still don't know time. We're going to have to find that. Let's plug this other stuff that we know. Y initial, well, that's what they want us to find. Find the height of the cliff. Alright? Y final is going to be 0 because it lands. XF, it lands 4 meters away. Xi can assume to be 0. So what I typically do then is I'll simply write my two equations here. And they want me to find the height of the cliff. Well, the height, that's yi. It's height here. H is this separate from this height over here, or this h over here being the hypotenuse. That's yi. That tells me right away that I'm going to have to use my x equation first to find t. But let's go ahead and plug it in, and I'll show you why. Xf is what we know that to be 4. Xi is 0. Vi in the x direction is 17.3 t plus 1/2 at squared. Well, there is no acceleration. Acceleration in the x direction, we said was 0. So that right there is going to go away. So I don't have a plus there anymore. Notice I got one variable here. I can solve for t here. Over here, yf, yf is 0. Yi is my height. Plus vit. Vi in the y direction was 10t plus negative 4.9 t squared, because half of gravity, or half of negative 9.8 is negative 4.9. Notice over here I've got two variables, h and t, so I can't find both h and t at the same time. So I'm going to go over here to find t, divide both sides by 17.3. We find t to be 0.23 seconds. I'm going to come over here now and 0 equals h plus 10 times 0.23 plus negative 4.9 times 0.23 squared. When we add these together, we're going to get 0 equals h plus 2.05, or the height equals negative 2.05 meters. This is the correct answer. Some of you may be saying, well, how are we getting a height of negative 2.05 meters? What I want you guys to do is figure that out. That's your job for tomorrow, and we'll talk about it. I'll catch you on the flip side.